All right, so here we have a shell method question. And why is that? Well, because we're given the density of ink droplets at a distance s meters away from the center, and we want to figure out the total amount of ink droplets found within 1 meter of the hole at the center of the flat circular disc. So this right here will be my disc, okay? Kind of poorly drawn, but that's okay, I guess. Here, from the center, we know that basically there's a hole here in the middle, and that the radius is 1, so this measures 1, and we're interested in knowing what's the concentration of all the ink droplets around in this area found within 1 meter of the hole at the center. So this measures 1 meter also. Okay. So we're using the shell method here. Let's think about this in a 3D way now, and hopefully my drawing will, or what I drew here, won't be too poor to show that to you. Hopefully it won't. So if we have f of x here, this function, and we go from a to b, in this case we're starting at 1, right, because there's a hole here in the middle, and we're going over to 2 because we're only interested in finding how many ink droplets are within 1 meter of the hole at the center. Okay, so it goes from 1 to 2, and then we take this area here. Actually, let me just give it a different color so that it doesn't get too confusing. If we take this area here and we spin it around the y-axis this way, it will form a solid, of course. That will look something like this. Hopefully you can visualize it with my terrible drawing. And this solid will essentially represent the number or the amount of ink droplets found within 1 meter of the hole at the center. So we go from 1 to 2, 2 pi r. Now our radius here is just that we were calling it s instead. Then we get just f of s ds. Okay, so then of course you can bring out the 2 pi since those are constants. So the volume would be 2 pi integral from 1 to 2 of s f of s ds. So the answer is D, and that's it.